Welcome back, dear students, to Physics Virtual Lab, Delhi Public School, Bangalore East, Grade 12. Continuing with the series, we move on to Experiment 3. Experiment 1 was based on meter bridge, Experiment 2 on potentiometer, and now Experiment 3 on galvanometer. Apparatus, galvanometer, battery eliminator, 2 resistance boxes, 2 keys, connecting wires. Theory. Resistance of the galvanometer G is given by the formula G equal to Rs divided by R minus S, where R and S both are resistors. Galvanometer is an instrument to detect current and it is a very sensitive instrument. So to understand this, let us study the circuit. The circuit has two parts. One is the main part of the circuit and then the branch circuit. This is the battery eliminator, whose potential difference across the battery eliminator or EMF with a very small internal resistance is denoted by E. You have a large resistance R which is connected to the galvanometer here. This is the galvanometer G. It is connected in series with the galvanometer to protect the galvanometer from getting damaged due to the flow of high current. Therefore, R will have a high value. Then coming to the branch circuit here, you have a small resistance S parallel to G and you have a plug key K2, and in the outer circuit you have another plug key K1. So this experiment has two parts. So in the first part, K1 is closed and K2 is open. So there is no current flowing through this part of the circuit. So the current, the main current here in this circuit will be I1 equal to E divided by R plus G. This is using simple Ohm's law, which is equal to K theta. Now this is based on the principle of working of the galvanometer, where current through the galvanometer is directly proportional to the deflection in the galvanometer, and K is the current per unit deflection. In the second part of the experiment, key K1 is closed and K2 is also closed. So now there is current flowing through this small circuit through S also. Adjust the shunt resistance S so that the galvanometer deflection is theta by 2. So here the galvanometer now should read theta by 2. In case in the first part, if theta was say 30 divisions, now theta has to be 15 divisions. Till we get theta equal to 15 divisions, we will have to unplug resistance in S. So this is the reason in this experiment we are using the half deflection method to find the resistance of the galvanometer. Now the current through the main circuit, the current in the circuit is I2, which is equal to E divided by R plus GS divided by G plus S, where R is in series with this combination of G and S, which are in parallel. So this is simple Ohm's law again, and current through the galvanometer is given by I dash equal to V divided by G, where V is the potential drop across the galvanometer, which is equal to I2 RP. I2 is the current flowing through this combination to the little small circuit here, and RP is the parallel combination of G and S divided by G again, which is equal to K theta by 2. This is as per the principle of working of the galvanometer. Now from 1 and 3 you see that I1 is related to I dash. Then again substituting for R2 from this equation and Rp as Gs and G plus S, we can simplify and get G equal to Rs divided by R minus S. Second part of the calculation is to find the figure of merit. So with these readings only we can find the figure of merit K, which is equal to E divided by R plus G into theta. For every trial we can find out K, and we need to find the average of all these readings as we are going to do it under observation and calculation. Let us understand the circuit and its components. We start with the main circuit. The main circuit consists of E, battery eliminator, R, resistance, G, galvanometer, and plug key K1. So corresponding to E, this is the battery eliminator. A battery eliminator can be set to any of these voltages ranging from 0 to 12 in steps of 2. Right now, this battery eliminator is set at 4 volts. This is the knob which is set at 4 volts. You could operate the knob like this. So this is 0, this is 2, and this is 4. So it is right now set at 4 volts. Then from here, this is the resistance box R. Here is the resistance box R. This resistance box has resistors ranging from 1 ohm to 10,000 ohms, and you can have any combination of this. Right now, the resistance of R is 2000 ohm. Next is the galvanometer, the main instrument which we are using. We need to find the resistance of this galvanometer. Galvanometer is a device to detect current. Galvanometer is a device to detect current, and it works on the principle that a current carrying conductor, when placed in the magnetic field, experiences a force. So whenever current flows through the galvanometer, this pointer is going to experience a force and it's going to move on the scale provided there. It detects current, it does not measure current. So when the current reverses the direction, the deflection in the galvanometer also reverses. You can see that this instrument is center 0, so it can deflect on both the sides depending on the flow of current. So it is graduated in divisions, and the number of divisions through which the galvanometer deflects is directly proportional to the current flowing through the galvanometer, which means to say, if current is high, then the deflection is more. It has two terminals, positive and negative. Again, the positive and the negative terminals can be interchanged. It's only that the direction of the current or the deflection will be interchanged. We need to find the resistance of this galvanometer and also calculate its figure of merit using half deflection method. Then next part of the main circuit is K1. This is K1, plug key. Right now the plug key is closed. If the plug key is closed, it means that current will flow in the circuit. You could even open the plug key. If you would open the plug key, means the circuit is open. So we finished understanding the components of the main circuit. Let us understand. This circuit is used for the first part of the experiment to find the current in the main circuit. Then is the second part of the experiment. In the first part, we'll have to measure the deflection in the galvanometer and from there calculate the value of current. The second part of the experiment is using this small circuit. Second part of the circuit. The second part of the circuit, you have one more wire from the galvanometer going to the shunt resistance. This is a smaller resistance box which varies from 1 ohm to 200 ohm, and you could use many combinations in this. Right now the resistance of S, this is denoted by S, and the resistance of this is right now 100 ohm. Then from S is K2, so from S this is K2. Again K2 is closed. If you need K2 to be open, then in the open circuit, then there is no current flowing through the circuit. This part of the circuit, no current will flow if K2 is open. The first part of every trial, K1 is closed and K2 is open. In the second part of each trial, both the keys have to be closed and the procedure will be explained. We will make the circuit connections. We will start off with the main circuit, which consists of the battery, positive of the battery to R. This is the battery, this is R, then galvanometer, then plug key K1 and back to the negative terminal of the battery, which is black, positive is white, so it's red. We start off with the red terminal. So this is the positive terminal of the battery. From the positive terminal to R, from the positive terminal to R, and then the other terminal of R to G, the other terminal of R, the other terminal of R to the galvanometer. Galvanometer, as I told you in the previous experiment, also positive and negative we could interchange, it's only that the deflection will get reversed. Then from the negative terminal of the galvanometer, it goes to the plug key. This is the other terminal of the galvanometer to K1. This is K1. So K1. So we have K1 there. And then from the other terminal of K1 to the negative of the battery. The negative of the battery. So we have completed the main circuit, and now we'll have to do the additional small circuit there, comprising of S and K2. In this small circuit, we have the galvanometer. We should start with the galvanometer, this galvanometer, and from the galvanometer it goes to S1 of the terminals of S. So we take the same side of the galvanometer here, and it goes to one side of the S here. Okay, and the other terminal of S goes to K2. So this is the other terminal of S which goes to K2. Other terminal of S to K2. Then from K2 it goes back to the galvanometer. So from K2 this goes back to the galvanometer. Goes back to the galvanometer. Here we have connected it to the galvanometer. We start with trial 1, part 1. In part 1 of all the trials, K1 will be closed and K2 will be open. But before we start all the trials, we need to record E, that is the battery voltage that we are using. So we switch on the battery, and this key is K1 and this key is K2. We need to close K1 and note E. Now according to the battery eliminator, you can see this pointer here. This pointer is at 4 volts, but we will take the battery voltage using a multimeter. So this is the multimeter, and we are going to take the battery readings using the multimeter. So we will take it, we'll round the figure and take it as 2.4 volts. 2.4 volts. In your observation tabular column, the first sentence reads EMF of the battery eliminator E. So there you have to fill it up as 2.4 volts. Okay, actually the battery eliminator here is giving you 4 volts, but the true output is 2.4 volts. So E is equal to 2.4 volts. Continuing with trial 1, you need to unplug 3200 ohm in R. So this is R. You need to unplug 3200. So this is 2000 plus 1000, 3000 plus 200, 3200, and ensure all the keys are tightened. All the keys are tightened. K1 is closed. K1 is closed. K2 is open. And you need to note the galvanometer deflection and post your readings in the chat box. Post your readings in the chat box. So trial 1 part 2, K1 is closed and K2 also is closed. So I close K2, and we need to adjust the galvanometer till you get the deflection theta by 2. You did note down the deflection theta. The deflection theta was 29 divisions. 29 divisions. When you divide it by 2, you will get 14.5, and when you round it off using the rules, you will get 14. Okay, so we need to unplug S. We need to unplug S till we get 14 divisions in the galvanometer. Deflection, 14 divisions in the galvanometer. So I have unplugged 50, 20 and 20. Please check the galvanometer. It is 14. It is 14. So What is the resistance S once more? You can count 50 plus 20 plus 20, 90. S is equal to 90 ohms. Please make a note. S is equal to 90 ohms. Trial 2, part 1. You need to unplug 3400 ohms in R. This is the big resistance box and this is R. So we had unplugged 3200. So another 200 ohm if I unplug, and all the keys are tight because I had tightened in trial 1. So we have unplugged 3400 ohm in R, and as I told you, for trial 1, K1 has to be closed and K2 need to be open. K2 needs to be open. You need to record theta, so please record theta values. Please record theta values and post it in the chat box. Please record theta values and post it in the chat box. So we continue with trial 2, part 2. The recorded theta values for trial 2 is 27 divisions. Note 27 divisions on the galvanometer. So in the part 2, K1 is closed and K2 is also closed. K2 is also closed. We need to adjust the galvanometer till we get, we need to adjust S till we get theta by 2 deflection in the galvanometer. So theta is 27 divisions. So theta by 2 will be 13.5, and when we round out 13.5, you're going to get 14 divisions. You need to get 14 divisions in the galvanometer. So it is 14 in the galvanometer, and let us check S. S is 50 plus 20 plus 20. Again, it is 90. I have not changed the resistance in S. So it remains 90. Trial 3, part 1. Unplug 3600 ohm from R. So previous trial we had 3400. So now 3600. So remove this 500 and 100 and tighten it. So you can count once more. 2000 plus 1000, 3000, 3500 and 100 here, which is 3600. Then for part 1, K1 has to be closed and K2 open. You have to note theta. Note theta and put it in the chat box. So trial 3, part 2, you need to tell me in part 1 what you got the value for theta as. Theta was 25 divisions. Theta was 25 divisions. And theta by 2 will be 12.5, which you will have to use your rounding off rules. When it is an even number before 5, then it will remain as it is. So when we round off 25 by 2, 12.5 is equal to 12. We round it off because we cannot, we do not have any 12.5 division. It has to be either 12 or 13. This is the reason we need to round it. Then we proceed with the second part, that is K2 has to be closed and K1 of course is closed. K1 is closed and we need to close K2 also and check S such that from the previous trial S was 90 ohm. S was 90 ohm. Now we need to check theta by 2. So theta by 2 has to be 12. Theta by 2 is 12. So S remains 90 ohm. S remains 90 ohm. Note down the value of S as 90 ohm. Trial 4, part 1. Unplug 3800 ohm from R. So previous trial it was 3600. So if we unplug 200 ohm, then it will be 3800 ohm. And K1 has to be closed. So K1 has to be closed. K2 should be open and note down the value of theta. Note down the value of theta and put it in the chat box. Note down the value of theta and put it in the chat box. Trial 4 part 2. Before we move on to trial 4 part 2, please note that the deflection theta is 24 divisions. 24 divisions in the galvanometer. Now in trial 4 part 2, K1 is closed and K2 should also be closed, and when theta is 24, theta by 2 should be 12. We need to unplug S till we get theta by 2 equal to 12. Theta by 2 is equal to 12 now in the galvanometer, as you see, for the same value of S. For the same value of S which was unplugged in the previous trial, 50 plus 20 plus 20, 90 ohms. So note down S as 90 ohm for the trial number 4. Trial 5, part 1, unplug 4000 ohm from R. So here we have 2000, 3800. So I will remove this 2000 and all the other plugs also have to be put in. Okay, and tighten all the plugs. So now you can read 2000 plus 2000, 4000 ohm unplugged in R. Then we need to close K1 and K2 is open. Note theta in the galvanometer. Note theta in the galvanometer and put it in the chat box. Trial 5 part 2. Before we move on to trial 5 part 2, the theta value is 22. The theta value on the galvanometer is 22. So part 2, we keep K1 closed and K2 also closed. We need to close K2. And what is theta by 2? If theta is 22, theta by 2 has to be 11. So we are getting 11. theta 2 as 11. For same values of S, I have not changed the values of S. So you can see the values of S, it is 50, 20, 20, which is 90 ohm. So note down S to be 90 ohm. With this we have completed all the 5 trials. Now the remaining columns, these are all calculations. So take 5 minutes and fill in these columns. Check your observation tabular column. E 2.4 volts. The values of R in ohms, 3200 for the first trial, 3400, 3600, 3800, 4000, all increased in steps of 200 ohm. Theta, the deflection in the galvanometer, 29 divisions, 27, 25, 24 and 22 divisions. S remains the same for all the trials, 90 ohm. Theta by 2, this is theta, and applying the round off rules, you get 14, 14, 12, 12 and 11 divisions. And G, this is by calculation with all the observed values. RS divided by R minus S. So for the first trial it is 3200 into 90 divided by 3200 minus 90. After simplification you get 92.6, and you repeat this for subsequent trials. You get 92.4, 92.3, 92.2 and 92.1 using the different values for the different trials for R, S. Figure of merit K is equal to E divided by R plus G into theta. E is same for all the trials, that is 2.4 volts, but R and G values you will have to take it from the tabular column corresponding to the particular trial number. And note the unit of figure of merit, it is ampere per division. Ampere per division. E by R will give you current unit, which is ampere, and theta unit is division. So ampere per division. For the first trial it is 2.5 into 10 power minus 5 ampere per division, and the subsequent trials 2.5 into 10 power minus 5, 2.6 into 10 power minus 5, 2.6 into 10 power minus 5, 2.7 into 10 power minus 5 ampere per division. Calculations. The steps of all the calculations for all the trials need to be shown in the record as well as during the board examination or any examination. So for trial 1, G is equal to RS divided by R minus S. For the first trial, 3200 into 90 divided by 3200 minus 90. After simplification, you get 92.6 ohm. Subsequently, we use different values for R, and of course for all trials we got S as 90. So after substitution we get these values. The simplification, you could just use a rough column and show your simplifications, but the formula and the substitution and the result need to be shown under calculations. Then mean value of G, you take all the 5 values and divide it by 5 and you get 92.3 ohm, which is equal to 92 ohm. Similarly, calculations for K, figure of merit, also need to be shown. So K is equal to E divided by R plus G into theta. For trial 1, E, for all trials of course E is 2.4, R plus G values are different, 3200 plus 92.6 into 29, and this gives you 2.5 into 10 power minus 5 ampere per division after simplification. Similarly for trial 2, trial 3, trial 4 and trial 5, you will have to substitute the respective values and simplify and find the mean value of k by taking all the values and adding all the values and dividing it by the number of trials, which is 5, and you get 2.6 into 10 power minus 5 ampere per division. Enter the results in your manual. Galvanometer resistance G equal to 92 ohm. Figure of merit of the galvanometer K equal to 2.6 into 10 power minus 5 ampere per division. Precautions. While you are conducting the experiments, you need to keep the following points in mind. All the connections should be neat, clean and tight. All the plugs in the resistance boxes should be tight. The EMF of cell or battery should be constant. Initially, a high resistance from the resistance box R should be introduced in the circuit. Otherwise, for small resistance, an excessive current will flow through the galvanometer or ammeter can be damaged. There could be errors in whatever we have measured using this circuit and apparatus due to the following reasons. The screws of the instruments may be loose. The plugs of resistance boxes may not be clean. The EMF or battery may not be constant. The galvanometer divisions may not be of equal size. These are a few questions for you to answer. How is figure of merit related to current sensitivity? How is figure of merit related to current sensitivity? Out of galvanometer, voltmeter and ammeter, which one has maximum and minimum resistance? When deflection is theta by 2, does it mean that current is I2 by 2? Will G be less than or equal to or greater than S? How do you increase the sensitivity of the galvanometer? Please think. With this, we have come to the end of session. A gentle reminder, note down the date, work on simulators and complete your record. Stay